Hello everybody. In this video, we are going to solve a problem from Fundamentals of Electric Circuits by Alexander and Sadiku's 6th edition. It is practice problem 6.4 and we are asked to determine the voltage across the capacitor. And the problem is given here as an initially uncharged 1 millifarad capacitor has the current shown in figure across it. Calculate the voltage across it at t equal to 2 milliseconds and t equal to 5 milliseconds. And the answer is given. In this problem, the mathematical expression for the current is not shown. Instead, the plot is given. The waveform of this current with respect to time is given. So from this, we need to find out the mathematical expression. Then only we can proceed further. So using line equation, we can find out the mathematical expression. So it is y minus y1 is equal to m into x minus x1. So again you can write this as y minus y1 is equal to m is the slope. So that slope can be calculated as y2 minus y1 divided by x2 minus x1 and then x minus x1. So we should know the coordinates here. This plot can be divided into two portions. So 0 to 2 is 1. Okay, up to this. After that we have another portion from this 2 to 5 milliseconds. So this would be your second portion. So for the first portion, when you consider this is your origin point or the starting point, then you have the sloped line. So this is your end point. So the starting point is your x1 comma y1 and the end point is x2 comma y2. So you know the value here, right? The starting point is 0 comma 0 and what is the x2 comma y2 or the end point for this ramp? It is nothing but 2 comma 100, isn't it? It is 2 comma 100 because along the x-axis you have this 2 value, along the y-axis you have this 100. So for this ramp signal, first you can write down this line equation. Along y-axis you have this current I and along x-axis t is taken. Okay. So with this introduction, we can proceed for this. So it is y minus y1, right? So y is nothing but I of t. What is y1 value? Y1 value is 0. That is equal to, what is y2 value? Y2 is 100 minus y1 value is 0. x2 value is 2 minus x1 value is 0. And x is nothing but t minus x1 is equal to 0. So when you simplify this, I of t is equal to 100 by 2, that is 50 times this t. So you get the ramp signal. This can be directly written as it is a ramp also. Okay. So I am giving the generalized one. So by looking at this, it has the slope of 100 by 2. So you can easily write it as 50t as it is a ramp signal. Otherwise, using this line equation, you can find it out. So now we got the expression for this I of t for the first portion. So it is where the t lies between 0 and 2. And then the same line equation can be applied for the second portion. So what's the second portion here? Second portion is from 2 to 5. Okay. 2 to 5 up to this. So if you look at this, you have the constant value up to this, right? It is nothing but this 100. I of t value is 100, isn't it? So directly if you want, you can write it out. You can write it as the t lies between 2 and 5 milliseconds. So like this way you can write it out, or otherwise using this line equation also you can find out the second portion's mathematical expression. So here it is when you look at this particular portion. Okay, so this is your starting point and this is your end point. So for the starting point, what is the value here for the coordinates? This is x1 comma y1, isn't it? And this end point is x2 comma y2. So if you look at this, x1 value is 2, y1 value is 100. Similarly, x2 value is 5 here, y2 value is 100. So using this, we can now go for this. So using this line equation formula, we'll calculate it for the second portion. So y is nothing but I of t minus y1 is what? y1 is 100, isn't it? That is equal to m is y2 minus y1. What is y2 here? Y2 is 100. What is y1? Y1 is also 100 divided by this x2 minus x1. So 5 minus 2 multiplied by this x minus x1. X values, it is the coordinate is t. X1 is nothing but this 2. But when you look at this, here you have this 100 minus 100, that becomes 0. So 0 multiplied by anything is 0. So it becomes I of t minus 100, that is equal to 0. Or we can say that I of t for the second portion is equal to 100. This is what we have written for the second portion already. Okay, it is between 2 and 5, the time value. Okay, so once we have got this equation for this I of t, we can find out this voltage across the capacitor. So what's the formula for this voltage across the capacitor? When you know this I of t, it is the formula number 6. So it is 1 by c integral v of t equal to 1 by c integral t naught to t I of t dt plus v of 0. So this is the formula. In this we can substitute this I of t. So v of t is equal to 1 by c. 1 by c is 1 millifarad, 1 by 1. Then integral for the first portion, it is 0 to 2, that is millisecond, that is the timing. I of t is given here. I of t is found out for this first portion as 50t into dt. It is also in milliseconds, sorry, milliamps. 50t dt, it's also in milliamps. Plus this v of 0 is equal to 0, as it is given as initially uncharged. Okay, so this particular portion indicates that this v of 0 is equal to 0. So now we can do this. This is equal to, for this 50t, the integration is 50 into t square by 2 with the limits 0 to 2, right? So you can write it as 50 by 2 into t square. Instead of t square, you can put it as 2 square minus 0 square, isn't it? Limits, by applying limits. So this is equal to 25 into 4. That means it is 100. And I'll put this unit as millivolts, V of t. So in this, some tricky thing is, something is to be understood by you. How to put this unit, that is important. So for that, in the integration, you have the variable which is to be integrated. That is nothing but I of t. We are going to integrate it with respect to time. So it is dt, right? So for this, you need to find out what is the um, given unit, whether it is amperes or milliamps. In our problem, it is given as milliamps. And for the time, it is given in milliseconds. So these two we need to multiply. So when you multiply this milliamps into this milliseconds, actually we get this millicoulombs. It is the charge. So actually, how do we get this? Current is dq by dt, isn't it? Current is rate of change of charge. So it is dq by dt by formula, isn't it? So for that, what is the unit? For q, it is coulombs. So we consider this as millicoulombs, as milliamps is available. So for q, it is millicoulombs. And for dt, that means time. It is milliseconds, isn't it? Multiplied by this milliseconds, you get this as cancelled. So we got this as millicoulombs. It is for these two only. Okay. So the variable of integration multiplied by this dt. So we got this millicoulombs only. But we have written this for V of t, isn't it? That is voltage. And this voltage and this millicoulombs, that means charge, are related with the formula. We know very well that Q is equal to CV, isn't it? From that, V is equal to Q by C. So already that capacitor is given here, isn't it? So The unit we got it as millicoulombs divided by the capacitance values given in millifarad, so that you get the answer here. That means the unit is millivolts. Okay, so this is how we got this. So it is 100 millivolts. It is the answer. Another thing is, you should not actually got confused with this t square by applying the unit and all. So when you take the limits here for the definite integrals, this should not be mentioned with the units. Okay, 0 milliseconds, something like that. It's just a constant. Okay, the limit is constant. That you should understand. So you should know that for definite integrals, that means when you put the limits, okay, with the definite values or the definite integrals, the limits are constant. It's the constant value only. Otherwise, you'll get it confused as t square. You can take it as t is in milliseconds. So millisecond square something, you should not put it. Okay. So if you have any confusion, you should avoid it. Only for this I of t and dt, you should put the unit. Here we have 1 by c. So for that 1 by c also we have to put the unit in order to get the unit for this v of t. Okay, that's it. So we got the answer for the first portion. Now we move on to the second portion. So the second portion is I of t is 100 with the time limits 2 to 5. So for that also we have to perform integration. So v of t for the second portion is equal to 1 by c integral I of t dt plus the initial voltage. So initial voltage is nothing but v of 2, isn't it? That is the initial voltage. It has already got charged because we put the limit from 2 to 5. So this is the initial one, right? So as usual, 1 by 1, this is 1 millifarad, right? So this 2 to 5 I of t is 100 into dt plus this v of 2 is 100 millivolts. So this is 100t with the limits 2 to 5 plus this 100. So this is equal to 100 times t is 5 minus 2, isn't it? When you apply the limits plus 100. So what it is? It is 100 into 3 plus 100. So it is 300 plus 100. So that is equal to 400. So already I have told you how to put the unit. So it is millivolts. So V of t is equal to millivolts for the second portion. So for the first one, we got the answer as 100 millivolts. And for the second one, we got the answer as 400 millivolts. Okay. So I hope you have understood. Okay, this is the answer for the first portion and this is the answer for the second portion. Okay. Okay, thank you. Hope you have understood.